Okay, in this section we're going to extend what we've learned about augmented matrices and apply it to a 3x3 problem. Once you can do it for 3x3, you have the details of the process down to where you could really extend this to any number. So let's do this first one by hand and keep notes of the process as we go. The first thing you notice that I've done here already is I've taken the second and first rows and interchanged them. Since I'm doing this manually, I didn't want to have a division by 3 right off the top and have some infinite decimals to round off in the very first step. So if I put this up here, I'm dividing through by 2 and put this one here. Okay? Okay, so for the first step, let's divide through by the lead coefficient up here. And so I have 2 divided by 2 is 1. Divide by 2, I get 2. Here I divide by 2, I get 1.5 minus 1.5. 29 over 2, well, 30 over 2 would be 15, so this is 14.5. Okay. Now, for the next step, I want to take, notice that 3 times this minus that will give me a 0 here, and so I want to do that process all the way across. So I'm going to take 3 times one of these, subtract the thing that's up here. Okay. So I'll use the calculator once I get into needing it here. So 3 times 1 is 3, minus 3 is 0. 3 times 2 is 6, minus 2 is 6 plus 2 is 8. 3 times 1.5 is that. I'm going to change the sign, it's negative. Minus 5 is minus 9.5. And 3 times this, 14.5 times 3 is 43.5, minus a minus 17, so I'll just simply say plus 17 is 60.5. Okay. Now I want to take this same top row and take 5 times this row minus this to get a 0 in the first place down here. So 5 times 1 is 5, minus 5 is 0. 5 times 2 is 10, minus a minus 6. So 10 plus 6 is 16. 5 times minus 1.5. So 1.5 and change the sign times 5. And then I'm going to subtract a minus 7. So add 7 is minus 0.5. And 5 times 14.5 is 72.5. Minus 7 is 65.5. Okay. Okay, at this point, we're finished with the top row and the first column. Okay, so first let's copy this top row and left column because those aren't going to change. 1, 2, minus 1.5, and 14.5, and 0, and 0. Okay? And the next thing I'm going to do is divide this row through by 8. So 8 divided by 8 is 1, minus 9.5, so 9.5, change the sign, divided by 8 is minus 1.1875. Okay, and then 60.5 divided by 8. 60.5 divided by 8, 7.5625. Okay, these are getting longer, but they're still fairly finite terminating decimals. So I'll write them all down. Okay. At this stage, if I were using a computer, I would take 16 times this row and then subtract this row or something like that. Since I'm doing this manually, I may as well take advantage of the fact that this number is simply twice this. So to get the 0 here, let's take 2 times this row minus this row. So 2 times 8 is 16 minus 16 is 0. 2 times this, 9.5, well 18, this would be 19, this is minus 19, minus this number, which is minus 0.5. So minus minus is a plus, 0.5 is minus 18.5. Okay, And so twice this number is 121 minus 65.5. 55.5 is the answer. Okay. And finally, let's divide the last one through by the lead coefficient. And I'm just going to write the results right here rather than copying everything over, just to save some space. So let's take this divided by itself. First, let's change the signs. I like to do the sign operations separately. So if I take this divided by itself, I get 1, and this divided by 18.5. So take 55.5, change the sign, divided by 18.5. Minus 3. That's nice. Okay, so these got replaced by these. All right, let's decode our answers from this now by back substitution. So x, y, z, this says z equals minus 3. Okay, let's find y. The second row here has 0x, but there's a y. So this says y minus this number times z equals that. And we know z. So I'm going to bring this to the other side, and so I'm going to have y is equal to that minus this times this, and minus this is minus a minus, okay? So let's just do it. 7.5625, so 7.5625 minus a negative 1.1875, change the sign, times z, which is minus 3. Comes out 4. What about x? So let's do the first row back substituting not only the z in this spot, but the y in this spot. Remember the equation, if I put it in literal terms, is x plus 2y minus 1.5z equals this. Well, when I say 2y, it's 2 times 4. When I say minus 1.5z, it's minus 1.5 times minus 3. Okay? So these numbers get substituted in here. So I'm going to think of these as being moved to the other side, and I'll start with that, and then subtract off this times z and subtract off this times y. All right? So this is 14.5 minus a negative 1.5, that's 1.5 and change the sign, times a negative 3, here's 3 and change the sign, equals so far is 10, and then minus 2 times 4, or in other words minus 8, comes out 2. Okay, so the solution is 2, 4, negative 3. Okay, now granted there was a bit of work there, but go back and look at what we did. It's all right there. Okay, in this amount of scratch work we've solved a 3x3 system of equations. Compare this to what we were doing a couple sections ago. Okay, so from here the next step is to program this into a spreadsheet so we can save ourselves even this much agony. Okay, so let's do a 3x3 spreadsheet. Okay, this is the same problem we did manually just a minute ago, and I'm going to do it differently than I did for the 2x2 because, as I pointed out at the end of that lesson, there was problems that could arise if one of the lead coefficients out here was 0, and you're trying to divide through by the lead coefficient in every case, and that can lead to trouble. So if I do this more the way I do it manually on a normal basis, it avoids that problem, because instead of dividing through by this, you're going to be multiplying using these numbers. And so you don't have a problem with division by 0. Okay, so that can basically avoid trouble down the line. So let's try and create a program that mimics the way we do this manually. Okay, first step is take the top row and divide through by the lead coefficient. So here I say equals that cell divided by the lead cell, which means I put a $ there to pin down the column in the denominator. I get a 1. Drag it across, and each of these, notice, the denominator is using the number that's in the A column. So C1 here divided by $A1. Okay, so we've gone through this before, but I'm just indicating it still. Now, I want to get zeros here and here. And the way I'm going to do it is, this says 3. I want to take 3 times this row and subtract this row. How do I know that it's 3? Where do I get the 3 that I'm going to use in my calculation? I'm going to take it from the lead coefficient up here. That's where. So I'm going to take the lead coefficient, which is 3, times this row minus that. Okay? So here I'm going to say equals the lead coefficient here, which is this, and put a $sign in front of the A. Okay? Times this. Okay? And then minus this one using a relative reference here, one straight above it. Okay? And if I copy this across, let's see that it comes out the right way in all cases. All right? So for instance, this one says $A2, so it's the lead coefficient, it's the 3 times B5, which is the 2. So 3 times 2, and then minus that number, which is the relative reference up here to B2. Okay? So that's done right. And so forth. All of these are done right. Let's just look at that one. This is A2 with a $1 on it, which is this number times this number minus that number. Okay? Now, can I pull this straight down? Let's see what happens if I do that. Nope, it doesn't work. And let's see why it doesn't work. And let's see if we can fix it. Okay, this was looking at the lead coefficient of this row that I'm interested in. And then it was times this top row here. And that's sort of the hint. The top row here, which is where the 1 is, then minus this thing. All right? What did I get here? This is $A3. That's this number here, the 5. But I multiplied it by A6, this row. I wanted it times that row. So I need to pin down the row number here. Okay, so let's do that again. So let's erase this. And let's come back up to here. And where I said A5, I want to make sure it's row 5 that I'm using. I don't want it to be a relative reference to some row. I want it to be this row. And so let's now look at it. It's A2 times $A2 times $5. Okay, so in this case I pinned down the first column. In this case I'm going to pin down this row. And so it's a little bit getting sophisticated, but it works, all right? And let's take that formula and drag it across. It doesn't change anything because we didn't have the problem there. But notice if we take this set of formulas and drag it down, aha, it canceled out and gave us a 0 where we needed it. So that's the key. I need to take the lead coefficient up here, and I need to pin down the row that has the 1 out front that I'm working with. So this is our second set of equations. Let's give it some color. Why not? So let's come down here and give it a lighter yellow. All right. So the bright yellow is our inputs, and this lighter yellow. Let's use this really light yellow here. Okay. So this bright yellow is our inputs, and this other yellow here is our intermediate results. Okay. And I'm not using bold. Okay. This top row and this left column I'm never going to touch again, so I'll just say equals that. I'm going to copy this across. Okay, just using a relative reference. 1, 2, 3, 4 spots up. And notice I can bring it down like this as well, because I want 4 spots up from here gives me that, and 4 spots up from here gives me that. So I'm copying over and down. So all I'm working with now is this subset of the original rectangular array. So let's look at this number here. In this spot, I want to put an equals that number divided by that number, but the first case it's relative, the second case it's the lead coefficient here, so $B6, and drag that across. Okay. Down here, I want to get a 0 here. Now, I could be sloppy at this point and not worry about the subtleties that I did up here, because this is my last row. I'm not going to have to reuse the formula going dragging it down. But let's maintain good discipline, because we're going to use this method to apply it to larger examples. So here I want to say equals 16 times this entire row and subtract this entire row. That's what I'm trying to do. So 16 in the first case referring to the lead coefficient. So let's point at the 16, but that's going to be a lead coefficient 16, so I put $1. Okay, times this number, but I want to pin down the row because I want it to really be row 10, although really it doesn't matter in this case, but I'm going to do it anyway. And then I'm going to subtract this using a relative reference, because I want it to apply to this or this or this as I drag it across. Okay, I got my 0, pull it across, and there we go. Okay, we're getting there. So the next step, let's highlight these and paint that light yellow again. Okay, for this next step, notice I'm going to be able to preserve the top 2 rows and the first 2 columns. The only things I'm going to change are down here in the corner. So I say equals that. I'm going to drag that across and drag it down 1. And then I'm going to take these 2 here and drag it down another. Okay, so everything in here is a copy of what's above it. All I did was copy the formulas around, and all the formula says is the number that's 4 units straight up. Okay, this is row 14, that's looking at row 10 in column B. All I want to do here is take equals this divided by this, and the denominator is interpreted as an absolute reference. The numerator is relative. And drag it across. Da-dum, I'm done. At least I'm done with this phase of the program. Okay, we're ready to backfill now. Let's start by let's go all the way up here. Let's go x space equals space, and let's go y space equals space, and z space equals space. All right, and make these all right adjusted. So I'm making this pair of cells look like it's an equation here. These cells, I'm going to make them left adjusted. Most of these are centered. Okay, how do we proceed? Well, that's our z. So we'll just say equals and point at it. There we go. Enter. All right, z is -3. How do we get y? We go equals. We're going to go this minus this times z. Remember what this is saying is this number is 1 times y, and then there's times, and then plus this number times z equals this number. If I bring this over to the other side, that's why I'm subtracting up here instead of adding. All right. So it's going to be equals that, then subtract because I moved it to the right. This number times z, and z is found right there. And there we got it. How about this one? This is equal to, do the same thing here, but twice. It's that minus this times z, and minus this times y. And there we go. Let's make these bold, and let's color code them somehow. How about, oh, there we go, teal. Cyan. I guess that's actually cyan. All right, there are your inputs. As soon as you're writing the inputs, you get the outputs. Here's your scratch work. If you were doing them by hand and you want to use this to check your work, it'll show you the intermediate steps and you can see where you went wrong if you went wrong. Okay, I'm going to put this on in the collection of files along with the videos. However, I would like you to actually try recreating this on your own. Play the video if you like to watch me do it here as though I'm just lecturing at the board, but I'd like you to actually try to set this up on your own. There's some subtleties here, and it's the process of doing this programming that's going to teach you the process of doing this method, probably better than doing it by hand. All right, there we go. Try some of the problems by hand and try programming this. In fact, if you program it like this on your own, I give you permission to skip over doing them by hand. I think you ought to do one of them by hand. Do one by hand, and you can use this beyond that. Now, there are some problems that are going to involve 4 or more. And so how do you extend this process to those problems? So that's something to challenge you. I would think it would be easier to program it to do, say, 4 or 5 variables in the same number of unknowns than it would to do it, even if it's just one problem, to do it by hand. Doing it once like this is easier than doing it once by hand. And then you can have a tool you can use forever. Okay, go for it.